So we are going to be doing scientific notation today, and then tomorrow Rachel's gonna teach about exponents, and then on Monday there's a exponent game that is like a clue game is what it is, and we're gonna do that together in class. Darcy Erie, I don't know if you remember her, she's coming in to help with it. So, all right, so we are doing, switching from standard form to scientific notation. And then we're gonna go from scientific notation to standard form. And then we're gonna multiply and divide with scientific notation numbers. So we'll look at that. So first of all, any time you're putting a number in scientific notation, you want to have, so this one we're switching from standard form to scientific notation. So you start at the decimal and then you make scoops until you get one digit, or how did they say this? Make scoops and stop when there's only one digit of 1 to 9 to the left of the decimal. So like here when you're doing this, you would stop when you go 1, oh that's weird. Let's see, I gotta do that. Okay, let's try this again. Okay. So when I'm doing that, I start at this decimal and I go 1, 2, and I stop here because I have one digit to the left of my decimal point. So it'd be 2.4 times 10, and when you move to the left, it's always going to be negative. But what I think of instead is this is a really small number, so it's gonna have a negative exponent. If it's a large number, bigger than 10, it's going to have a positive exponent, okay? So if we go to our next page here, so any number less than 1, okay, if you have a number less than 1, it's gonna have a negative exponent. So think of it as, if it's small, less than 1, negative. If it is greater than 9, then it's gonna have a positive exponent, okay? So for this question right here, they're giving us a number. They're saying 6,482,000,000. So do you guys know if it's 6,482,000,000, how many circles or zeros am I gonna have? 6, yes, okay. Alright, now we need to put that in scientific notation. So our decimal currently is right here. So I'm gonna move that 1, 2, 3, 4, 5, 6, 7, 8, 9. And I stop when I have one digit to the left of my decimal. And then when I write that, it would be 6.482 times 10. I moved it 9 places. It's a big number, so it's gonna be positive, okay? So that is which one, C? All right, then when we look at this one, we have 0.1, 2, 3, 4, is there 6? Yep, 4, 5, 6, and then a 2. And we wanna go to scientific notation. We start at the decimal, and I'm gonna move it 1, 2, 3, 4, 5. Do you think I stop right there? Can I stop it when it's 0.2? No, I have to go one more place. You have to go until you have one digit to the left of your decimal point, okay? So this is 2, or you could write it as 2.0 if you wanted to, either way, times 10, and I moved it 1, 2, 3, 4, 5, 6, 7 spots. And do you think that would be positive or negative? Because it's so small. Very good. Okay. Now, if I look at this one, I'm gonna just stay up here and do it, and I'm going 1, 2, 3, 4, 5, 6, 7, 8, 9. And do you guys get I'd stop when I get 1 past the 7? And that was 10, okay? Now I would write this as 7.53 times 10. I believe 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And would it be positive or negative? Negative, very good. So this one right here, all right? Now, this one is 321 million. So 321, and million has 6 zeros, okay? And if we try to move that over, start with your decimal here, and we go 1, 2, 3, 4, 5, 6, 7, 8. So it'd be 3.21 times 10 to the 8th. Would that be positive or negative? Yeah, because it's such a large number, it's positive. Okay. Now, the next thing that we're gonna do is we're gonna take a number in scientific notation and switch it to standard form. When I do this, a lot of times I just think of, if it's a positive number, I wanna make that number big. So I add zeros to it, okay? If it's a negative number, I wanna make it small, so I move my decimal point over and I add zeros after the decimal point to make it very small, okay? So, the way, like a way you can remember it, if you're ever in doubt, is you could think of the word negative and left. And do you see how they both have an E in it? That negative, if you have a negative exponent, you move to the left, okay? If it's positive, then you move to the right, and what they do for that is they say there's an I in positive, but there is a negative too. I don't know. But negative to the left, positive to the right, okay? But like I said, I usually just think of, I want this number big, so I'm gonna add zeros. If it's small number, I add zeros at the, before, like I put a decimal point and add zeros there. So this one says, which represents the population of China in standard form. So I have 1.269, and I wanna move it the decimal 9 spots. Since it's a big number, do you guys agree we're just gonna add a bunch of zeros? So we're gonna go 1, 2, 3, 4, 5, 6, 7, 8, 9. And in these scoops, I add zeros. Okay? Then I can go back to look at what is that number. I have 3 zeros here, so there's a comma, 3 zeros here, so there's a comma, 3 numbers, comma. So isn't this really like 1,269,000,000? And wouldn't that be this one right here? Do you guys get that? Okay. Now this one is 6.8 times 10 to the negative 4th, okay? When it's negative, I just think I have to make this number small, so it's gonna have zeros in front of it after the decimal. So I go 1, 2, 3, 4 spots. That's where my decimal goes, and these are zeros. So it's gonna be 0.00068. Okay. So this shows you what they are talking about if you ever get confused. positive is right, negative is left. Carla added several large numbers on her calculator. The answer displayed 8.09 times 10 to the 10th, okay? So if we have 8.09 times 10 to the 10th, we would just make the number bigger by adding a bunch of zeros. So I'm gonna go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I'm essentially just adding 8 zeros there. So it's gonna be 80,900,000,000. Okay. And if you were on the test and you wanted to make sure, like, did I get this right? You could go to this and put it in scientific notation and make sure it's that, if you wanted to check it. What is 5 times 10 to the negative 4th written as a decimal? So it's gonna be a small number, right? So if I have 5 and I wanna write it as 10 to the negative 4th, I go 1, 2, 3, 4, my decimal ends up there, and I add 3 zeros. So 0.0005. Now, this one says Sean said that in standard notation, 7.142 times 10 to the 7th will have 7 zeros after the 2. Okay? So what he says is if we write this in standard notation, it would have a 2 and then 7 zeros. Do you think he's right? No. Because if we wanted to do that, and I had 7.142, wouldn't I have 1, 2, 3 spots taken up there already? And then I would need 4 more, correct? So isn't this what we would actually get? So let's just say, no, there would only be 4 zeros after the 2. Alright, now if I go to this one, I don't know if you guys have ever seen this before, but if you ever see on your graphing calculators as you get to using them more and more, if you see something like 3e to the 6th, graphing calculators, and actually a lot of calculators, will do that when a number is in scientific notation. And what that means is if you went 3 times 10, this is the exponent of your 10, okay? Did you learn that already? Did you guys know that? Okay. So now, they want you to take that and just say which one it is, and that's this one right here. So it's like 3 times 10, and this is your exponent on the 10 is your 6. Okay? So this one is 4.5 e, so that would be times 10, and then negative 4 would be my power of that 10. So I'm going to write that in standard form, and I'm going to move it 4 places. I want to make the number small because it's negative. So 1, 2, 3, 4. And it would be 0.00045. Okay. Then we're going to skip that. And this is the part where I think it's a little bit harder. Okay. So what they're doing here is they are having us write numbers. They're going to multiply or divide scientific notation numbers, and we have to write them. Actually, in this case, I think we're going from standard form to scientific notation. but the numbers are gonna be multiplied, okay? Let me just look. Actually, no, I was right. We're going from scientific notation, and multiplying them. Now, one of the things that's true with this, from what we have, we can't use a calculator on this part of the test, okay? Now, there is something called Lars from Mars, okay? And what's gonna happen is, this is just a way to remember this. So the Lars part is what you really wanna remember. The L means left, A means add, R means right, S means subtract, okay? We'll come back to that where we use that. So when you have two numbers that are in scientific notation and you're multiplying them or dividing them, the first thing we do is we take our two numbers and we multiply them. So I would take 2.7 times 5.5, but again, you can't use your calculator, you have to do that by hand. And they got 14.85, okay? Then, this is where the Lars from Mars comes into effect. We have 10 to the negative second and 10 to the third, and we are multiplying, okay? What Lars from Mars is saying is when you add, no, hold on. Where are my rows for this? Oh, right here. When you're multiplying, I'm struggling today. When we're multiplying, we add the exponents. So down here, we're multiplying, so we'd go 10 to the negative second plus 3. That's what this is. So now we would have a number that's 14.85 times 10, and when we add these together, it's to the first power. But we can't leave it there because we don't have that number in scientific notation for 14.85, okay? We have to move that decimal over one spot, okay? And again, that's where the Lars comes in. If you move it left, you add to your exponent, however many places you have to move. If you move it to the right, you subtract. Now on this one, I moved left 1, left is add, so you add 1. So this would be 1.485 times 10 to the second. So that's where the Lars comes in, okay? If you're moving your exponent to the left, you add. If you had to move it to the right, you would subtract. Okay, everybody understand that? Okay, so let's try one of these. Like I said, first thing, you can't use a calculator on this. So if I have 6 times 2.5, I'm gonna just, some of you could probably do that in your head, but remember 2.5 times 6 is 30, 0, carry the 3. 6 times 2 is 12, plus 3 is 15. And do you guys remember if it has one decimal point here, you have to have one decimal point there, so it's 15. Okay? So this is gonna be 15 times. Now this is a product. And if you remember back here, if you're multiplying, you add the exponents. We're multiplying, so what I'd have is 10 to the 3 plus 5, which is times 10 to the 8th. Now, is that in correct scientific notation? No. Do you guys agree I have to take it and move it one place over? And remember, left, add, right, subtract. I moved it one place to the left, so do you get I have to add 1? Okay, so this would be 1.5 times 10 to the 9th. Everybody understand that? So you have to remember this. If you move your decimal to the left, add. If you move it to the right, subtract. No, I didn't want to do that. Write the product then in standard form. So this is one of those that you have to write it all out. There's no answers for this. So we would just go 1.5 and we would move our decimal 9 places. So 1, 2, 3, 4, 5, 6, 7, 8, 9. And I would add zeros in each of those. Okay? So then when I do this, I have a comma here, I have a comma here, and a comma there. So it'd be 1,500,000,000. Okay. All right, so we have another one where we're subtracting. And again, what you would have to do here is you would have to multiply 7.25 times 8, okay? 8 times 5 is 40, so I'm gonna put 0, carry the 4. 8 times 2 is 16, plus 40 is 20, so I put 0, carry the 2. 8 times 7 is 56, plus 2 is 58. And how many decimals do I have to put in my answer? 2, because there's 2 here, okay? So my answer is 58 times. Now the rule for this, in case you forget where to look, is right here where we want to be looking at these. If we're multiplying the two scientific notation numbers, we add the exponents. So if I look, okay, I'm gonna have 10 to the 7th plus a negative 4, which is 58 times 10 to the 3rd. Is that in scientific notation? No. Don't I have to take this and move it to the left? Think of Lars, when you're moving it to the left, do I add the 1 or subtract? I would add. Left is add, so it's 10 to the 4th. Okay, now we're skipping this page, okay? And we're just gonna look at this one more time, because this time we're gonna be dividing the scientific notation numbers. So again, you're gonna have your two numbers, you're gonna divide them, and you're not gonna love that because you have to do long division to divide those because you don't have a calculator. Then, in this one, we're gonna be dealing with division. So instead of adding the exponents, we're gonna subtract the exponents. So you're gonna get a number like this. You're gonna divide 4.8 or 4.5 divided by 8, okay? We're not gonna do that one, we'll do them on the next. They got 0.5625, and then when you're dividing, you subtract the exponents. So it's 7 minus 2, so it's 10 to the 5th. This is not in scientific notation. I have to move it 1 to the right. So remember, left, add, right, subtract. So it'd be -1, and we would get this, okay? So let's go and try when we're dividing. Now 4 divided by 8, what is that as a fraction? 1/2, what is that as a decimal? 0.5, right? Okay, so we don't really have to long divide that one. And then we go times 10. Now, we're dividing. Do we add the exponents or do we subtract? Subtract, very good. 8 minus 4, so we get 0.5 times 10 to the 4th. Is it an okay standard or scientific notation? Don't I have to take this and move it one place? So think of left, add, right, subtract. Did I say I move it to the left? I'm moving it to the right. So wouldn't I have to subtract 1? So I'm subtracting 1 and I get 5 times 10 to the third. Do you guys get that? Anyone have questions on that? So the reason I subtracted them first is just when you're doing scientific notation with dividing or adding, or multiplying, if you're dividing, you always minus these or subtract. Then when you're moving the decimal point over, that's when you think of left, add, right, subtract, and I was moving it to the right, so I subtracted. Let's try another one. So this one, you almost have to do long division. So let's see if you guys remember this. If I go 5 into 7.5, right? 5 goes into 7 one time, so I put a 5 here, subtract, okay? 7 minus 5 is 2, and then I'm gonna bring my, no, I don't have to. Then I would just bring my 5 down, but I put my decimal point up above that, right? And then 5 goes into 25 5 times, so it's 1.5, okay? So when I divided those, I got 1.5. Now, what do I do with the exponents if I'm dividing? Subtract, right? So I get 6 minus a negative 2. What happens in math when you have minus and negative? You turn them to a positive, so it's 8. That would be your answer. Okay. We have one more and then we're done. Okay, so if I look at this one, I have to divide these two. So I have 4.8 is dividing into 1.2. Do you guys remember if you have a decimal point in both, can't you move the decimals over in both of them, right? Do you remember that? So now it's like 48 goes into 12. Does 48 go into 12? No, so I can put a 0 up there, okay? Bring my point up above, and then I put a 0 here. Now, does 48 go in, how many times would 48 go into 120? So if you tried 48 times 3, that would be 144, so that's too much. And you guys might know 48 times 2 is 96, so we can do twice, okay? So 2 times 48 is 96. I subtract that. 120 minus 96 is 24, okay? Does 48 go into 24? No. Okay, so I add my 0, I bring my 0 down, okay? Now, does 48 go into 240? And it does. So if you tried like 48 times 5, let's try that. 8 times 5 is 40, 0, carry the 4, 5 times 4 is 20, add 4 is 240. So it goes in there exactly 5 times, okay? 5 times 48 is 240, and that's 0, okay? So our decimal is 0.25 times 10. What would you get when you do these exponents? Would you go -6 plus 4 or -6 minus 4? Yeah, and -6 minus 4 is 0.25 times 10 to the -10th. And then what we would have to do is put it in scientific notation. Think of Lars. When you move to the right, what do? You subtract. So we get 2.5 times 10 to the -10th minus 1, which is 2.5 times 10 to the -11th. And that is right here. Did you guys think that was hard? Kind of? Not bad. Alright, so this is your assignment, and I'll get my key out for it in case it's not on Schoology. And then tomorrow you're doing exponents with Rachel. And that'll be the last time anyone teaches, because Rachel, I think, has 2 more Fridays, but she already taught once, so she'll be done teaching after tomorrow.